Hi everyone, in this video we'll discuss about slip and significance, rotor induced frequency of the EMF, next one rotating magnetic field, next on applications of three-phase induction motor. So coming to the slip is defined as the difference between synchronous speed to motor speed. S is equal to, where S is equal to ns minus n is known as slip. Here S is equal to ns minus n. So this is called slip definition. So percentage of slip, if you consider ns minus n divided by ns. ns minus n divided by ns. So coming to the significance, when motor rotates at synchronous speed, so here ns is equal to n, then s value is equal to how much? S value is 0. When motor is not rotating, that is standstill position, n is equal to 0, that case is when n is equal to 0, slip is equal to 1. Slip is equal to 1, right? So this is about the significance of slip, right? Next one, rotor induced frequency of the EMF. So coming to that one, so here rotor frequency Fr is equal to S into F. S into F. So next one, slip speed ns minus n. So depends upon the load on the motor, right? So next one, motor speed we can also write from the slip formula. So from this slip formula, if you simplify, motor speed n is equal to ns into 1 minus s. In an induction motor, the slip value ranges from 2% to 4%. 2% to 4%. So this is about rotor induced frequency of the EMF, right? So next we'll see about rotating magnetic field. The concept of rotating magnetic field, here the induction motor starts to rotate. So what will happen? Inside flux will produce. So here, so we have a diagrams here. So this diagram represents the three-phase winding is connected to the supply, first diagram. So it is similar to first diagram. So here A, B, C are the three windings. So it is connected to three-phase supply. So here, so these are the three windings will rotate inside the induction motor. So coming to the once motor starts rotates, here three fluxes will produce. So that is pi r, pi y, pi b, right? The phase difference between three fluxes is 120 degrees. 120 degrees here. So R phase to Y phase here. R phase to Y phase is 120 degrees. Similarly, Y to B is 120 degrees and B to R is 120 degrees. Here we are considering the four cases. One, when here when 0 angle is 0 and 60 degrees, 120 degrees, 180 degrees. 180 degrees here. When it is 0, angle is equal to 0. Here, what are the fluxes are producing here? So what is this flux? Pi b and pi y. So pi r is 0 is here. So here, see in this first diagram, pi b is positive and pi y. So this one. So this one is negative is here. So this flux. So we need to find out what is the total flux inside the three-phase induction motor. So pi t is equal to 1.5 into pi m. So similarly at angle is equal to 60 degrees. So which is the flux is 0, pi b is 0, pi r is positive and pi y is negative. Pi r is positive and pi y is negative. So we have to calculate the resultant, that is the total flux inside the induction motor when angle is 60 degrees. Same, here also will get, so total flux will be 1.5 into pi m. Similarly, when angle is equal to 120 degrees, pi y is 0, pi r is positive, pi b is negative. Pi r plus positive and pi b is negative, resultant flux is same, 1.5 into pi m. So next one, similarly 180 degrees also. So 180 degrees, pi r is 0, pi y is positive, pi b is negative, easy, right? So this is four cases. So we will see the one case how pi t is equal to 1.5 into pi m. So in case 1, so these are the fluxes. Pi r is equal to pi m into sin omega t. So that is equal to pi m into sin theta, you can write. So pi y is equal to pi m into sin of omega t minus 120 degrees. So in place of omega t, if you take theta, so theta minus 120 you will get. Pi b is equal to pi m into sin of omega t minus 240 degrees. So pi y lags the pi r by 120 degrees, pi b lags the pi r by 240 degrees. In first case, so pi r is equal to 0 and pi y and pi b will presence. So pi b is positive and pi y is negative is here. So here, so if you substitute the theta or omega t, omega t is equal to 0 or theta is equal to 0 degrees. So here we will get, these are the fluxes. So if you consider, so here pi r is 0, pi y is minus 3 by 2 into pi m. So substituting these in these equations, you will get these equations, pi y, pi b is equal to root 3 by 2 into pi m. So from this phasor diagram, so we need to calculate the total flux. So apply Pythagoras theorem to the phasor diagram. So if you calculate pi r is equal to 1.5 into pi m, you will get it. So this is the resultant or total flux inside the induction motor when theta is equal to 0 degrees, right? So this is about rotating magnetic field. So if you take case 2, theta is equal or omega t is equal to 60 degrees, same thing you will get. And 120 degrees, theta is equal to 120 degrees also, you will get same thing. So next one, 180 degrees, if you take theta value, so if you simplify the phasor diagram, you will get 1.5 into pi m. So this is the rotating magnetic field concept, right? So next we will see the applications of three-phase induction motor. So here in three-phase induction motor we are using two types of rotors. One is squirrel cage and another one is slip ring. So first, coming to the squirrel cage rotor. So if you are using squirrel cage rotor in induction motor, that type of induction motor is known as squirrel cage motor. If we are using slip ring rotor in three-phase induction motor, the type of motor is known as slip ring induction motor. So slip ring motor. So squirrel cage motors are you are using in water pumps, grinders, lathe machines, printing machines. So this type of motors, no need to control the speed. So yes, squirrel cage induction motors, we cannot control the speed. So the water pump speed we no need to vary every time. Grinders we no need to vary. Lathe machines also we are no need to vary. Printing machines also no need to vary. So single gauge induction motor speed we cannot vary, but we can vary by applying the load. Somewhat we can apply, not more about the speed. Next one, slip ring motors, lift, elevators, cranes, compressors. So this lift, elevators, cranes, so always we need to control the speed up to one certain level. So slip ring induction motors speed we can control because of that. So these motors are using in lift, elevators, cranes, compressors and etc. So this is about applications of three-phase induction motor, that is squirrel gauge and slip ring. So next video we will see about why it is required, necessity of starter and problems on induction motor, right? Thank you all.